Welcome to Chapter 8, Introduction. When students are finished with this chapter, they will be able to recognize the two types of geometric solids. There are two types. You have prisms and cylinders, and you have pyramids and cones. For example, a prism would be an object like these. Okay? Any of these are a prism. I'll explain more about it in a minute. These are the prisms. And then on the other end of the spectrum, you have pyramids. So you would have pyramids. You could have the triangular bottom. You could have square. Or you could have what we call a special type of pyramid, which is a cone. Going back and talking a little bit more about prisms, the key is that they are the same throughout. And what I mean by that is if you take a slice of any one of these, in order to figure out where the base is of it, because that is the most important thing that we need to be able to do, is figure out what the base is. Many times a student will look at an object like this, if it's laying like this in the diagram, and they will think that this is the base because it's sitting on this. That is not what a base is all about. A base is here and here. And the way we determine that is right here. In this case, if I were to slice this like this, parallel to the bases, I will get the same shape of triangle, just like this. Every slice will be a triangle just like this. If I take this, obviously, no matter what I pick, it's going to be the base because it's a cube. Not much sense talking a lot about that. And this, technically, I could slice it this way or this way, and I'm going to get the same shape. Slice it this way, and I will get nothing but rectangles like this. Slice it this way, and I will get nothing but squares like this. So these two objects here, students don't tend to confuse. This is the one that students confuse when looking for a base. Again, in order to find the base, if I were to put it here and call this the base, if I sliced it like this going through, I would continue to get rectangles, but as you can see, they would get narrower and narrower and narrower. And that is how you determine that this is not the base, this is not the base, this is not the base. This is really a very important point about prisms. If I slice here, 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 I get triangles of this shape throughout. That makes this or this, either one, the base. And we'll get to why you need to know the base in a minute. And then lastly, in regard to the prisms and cylinders, this is the most closely related. We call it the cylinder. Again, if I slice it this direction, I get every single circle is going to be the same size. That shows that this is the base. And then in this case, this would be the height. You could call this the base. This would be the height from here to here. In this case, you would have height here. This would be the base. And then in this key one, this has to be the base, or this, doesn't matter which, and this is the height. Another way to look at it is once you determine the base of the object, the distance between the two bases is always the height. So even if I lay this down like this is not the base, this is the base. And this lateral side here is the height, even though it's not up and down. Height has nothing to do with up and down when we're talking about a prism or a cylinder. This is the height here. If it's laying here, this is a base, this is a base. The distance between the two bases is the height. And then we switch to the pyramids and the cone. In this case, it's really easy to determine what the base is because the singular point represents the top of the figure, whether it's laying like this, or like this, or like this. This is still the one singular point in each case, and therefore this is the base, base, and base in this case. Okay, so you can find the area of the base, and then the height is calculated as though you have a straight line across here, and it's the height is from this surface to this surface. So you have to kind of, in your mind's eye, picture, and that's the way they will show them in the diagrams. There will always be a dotted line inside of, like if you imagine a point right there at the very center of the base, up to the top here, that is the height of this pyramid. This is the height of this pyramid. And if you look at it, in this case, you can say that the height of all three, pyramid, and cone, the height is the same in every situation. So remember, if we can slice it and it has the exact same, we can find a way where it has the exact same slices throughout, those are prisms and cylinders. If we slice it, and no matter how we slice it, you have a different size, but the same shape, but a different size because it comes to a singular point, that is the pyramid and the cone. Now, the key to all this is, what we're going to be working on this chapter is volume, and then later on surface area, but for right now, volume. And in order to calculate the volume of one of these shapes that I've been showing you here today, you must be able to recognize the base, large B. What they mean by large B is the area of the base. The area of the base. That's really important that you understand that even though they just have the letter B, many students just think that it's the base. So I could take the base of this triangle, multiply it by the height, because that is the formula. It is the area of the base, large B times the height is how we calculate the volume of all of the prisms, all of these here, okay? We calculate the area of the base, multiply it by the height, we have the volume. Calculate the area of the base, multiply it by the height, we've got the volume. Look at one you already know. Area of the base, that's length times width times the height. Length times width times height, you've got the volume with that solid. Leave that one for last. Again, it would be length times width times height, the 3 dimensions, okay? But it's truly the area of the base times the height. Now when we get to this is the most complicated one, and we'll spend more time working on this later. But we have to find the area of that triangular base and multiply it by the height, and it's really quite easy. But the problem arises when you look at this in your book on page 584. You have to find the base of the triangle and multiply it by the height of the triangle to find the area of the triangle, and then multiply it by the height of the prism. This is where things get complicated on this one. When it comes to the other type, prisms and cones, we find the area of the base, multiply it by the height. Find the area of the base, multiply it by the height. Find the area of the base, multiply it by the height. But obviously there's one more step. And in this case, it's really simple. Divide by 3. This is 1/3 the size of this. Okay? Area of the base times the height. Area of the base times the height, and divide by 3, and you have that volume. In this case, this is 1/3 the size of this. Find the area of the base, multiply it by the height, you get that volume. Find the area of the base, multiply by the height, divide by 3, and you would have this volume. And then lastly, when it comes to a cylinder versus a cone, you find the area of the base, multiply it by the distance between the two bases, or the height as we call it, and get the volume of this. Do the same thing here, area of the base times the height, divide by 3, and you calculate the volume of the cone. Welcome to Lesson 1, Chapter 9, Volume of a Cylinder. Turn to page 590 in your book and please follow along. We will go through example problem number 1 first. In problem number 1, you have a cylinder. So we're going to use the volume formula. Volume is the area of the base times the height. Come back to this later. It's in the book. So we have B, which is the area of the base of a cylinder, would be the radius squared times pi. So it's pi r squared. So find the radius, and it's pi times the radius squared, and then you multiply that by the distance between the two bases we talked about earlier, which in this case we're going to call it the height. So it's the distance between the two bases. So if you look at the diagram in the book, our formula then for a cylinder is pi r squared times the height. So the volume is pi times the radius. In our particular problem here, the radius is 5, so it's r squared, so 5 squared times the height, and height is 8.3. And remember, whenever you do a problem like this, you only round once. In this case, it's easy. Use the pi key. We are always going to use the pi key. Do not round to 3.14. So it's in your calculator, it's pi times 5, square it, times 8.3, and you get an answer. And right here is your answer. 651.9. Notice that it is centimeters cubed, because remember, when we're talking about volume, volume happens in three directions. If we're talking about this, it's easier to see the three directions here, the three dimensions, I should say. We have length, height, and width. Three different dimensions, therefore it is cubic units. So we have 651.9 cubic centimeters. In problem number 2, again, we have a diagram. We've got a diameter, however. They give you the diameter of 16 and they give you the height of 20. The height of 20 we can use directly. However, we don't want the diameter. We don't want the full distance across the circle. So remember, if they give you this distance here, you have to cut it in half to come up with the radius. So if the diameter is 16, the radius, of course, must be 8. Very quick problem. Same formula. Volume equals area of the base, which is this part right here, times the height. The area of a circular base is pi r squared, multiplied by the height. So we have pi times the radius, 8 squared, times the height, which is 20. Again, put it directly into your calculator. Pi times 8 squared times 20, and you get 4,021.2, again, cubic unit, so cubic inches. Okay, so two separate problems, very simple problems to do the volume of a cylinder. I would like you to hit pause now and do problems A and B. Okay, sample problem number 3. We have, again, a diameter of 2, and we are given a height of 1.5. Right in the word problem, if you read through it, you'll see that. Since the diameter is 2, the radius will be 1. Fortunately, we used the correct number down here. So for diameter of 2, we have a radius of 1, pi r squared times the height again, same thing we've been doing. Volume equals pi times the radius, 1 squared, times the height of 1.5. Plug it right into the calculator, and you're going to get 4.7. Notice it says 4.7 in the book, and we'll talk about that in a minute here. Then you take your 4.7, and because the word problem said that it was 1.8 ounces per square inch, we have to multiply by that factor of 1.8 ounces to find out how many ounces this much volume of that would weigh. So that's why we multiply by the 1.8. And our rounded answer is 8.5 ounces, and I agree with that with the book. However, if you take this number here and you do not round it to the 4.7, and remember, we only round once in math. You should not round that number. Don't round it. Multiply it by 1.8, and you get 8.48, not the 8.46 that they have in the book. In this particular case, it rounds to the same number. Each of these round to 8.5 ounces. So it's not a big deal. But make sure that you notice that. Please do not round more than once on any math problem. And now, once again, hit pause, and please do letter C. Sample problem number 4. Volume of a cube. We've got a complex solid here where we are going to find the volume of a composite solid. And all that means is a composite solid. You can look at the one on problem number 4, and then the one that you're going to do, letter D, is a rectangle and a half of a cylinder. So when you look at this particular problem, you should be able to look at it and see that I can find the volume of a cube in this case, and then it has a hole drilled through it, which makes the volume of a cylinder. So if I deduct the volume of the cylinder, the amount that was drilled through the little bead, I will find out what is left. If I take the volume of the cube and I deduct what was drilled out, that cylindrical opening, I will have what's left for volume. So it is the volume of the cube minus the volume of the cylinder. The volume of a cube is the area of the base times the height. The volume of a cylinder, area of a base times the height. Notice it's cube and cylinder here. So the volume of the cube is easy. It's a cube, so it's 12 times 12 times 12, which is 1,728. Okay? The volume of the cylinder is, once again, the area of the base, which is a circle, pi r squared, times its height. Well, if you take a look at the diagram, we have a diameter of that hole as 2, but we're going to reduce it to 1 because that would give us a radius. So it's pi times 1 squared times 12, and I get 37.7. So if I take this 1,728 minus the 37.7, I get 1,690.3 millimeters cubed. Again, a cubic unit. I would now like you to press pause and do letter D.